All right, guys, Friday, May 8th. We're starting in on section 11.1. We have 2 chapters left, you guys, and then we're done. So chapter 11 only has 5 sections, so it goes a little bit quicker. And we're going to be dealing with area and perimeter predominantly here. So that'll lead us into chapter 12, which is surface area and volume. But for now, we're going to stick with area and perimeter. So rectangles and squares we should be comfortable with. We're going to talk about parallelograms and triangles today. Okay, so base of a parallelogram and height of a parallelogram. Okay, I'm going to sketch a rough parallelogram here, okay? The base is just one of the sides. It doesn't matter which one, you guys, okay? The height is then the perpendicular distance between a base and the side parallel to it. So in this case, this is going to be the height. The only way the height would be a side is if we had a right angle there, so like a square or a rectangle. So we got to be a little bit careful with what the height is. Don't assume it's going to be one of the other sides, okay? Same thing with the triangle. If I pick a side to be the base, the height is a line that goes from the vertex opposite it perpendicular to that, okay? So in each case, these are perpendicular. This is the height. So just be aware of that when you're calculating area, because the height is part of the formula for finding the area in each of these, okay? So the area addition, the area of a region is the sum of the areas of its non-overlapping parts. So if I got a shape like a block L or something like that, which I don't have a formula for, but I could break it up into 2 rectangles and find the formula for each of those and add them up. That's all this is saying, okay? In general, and I would find a place in my notes in chapter 11 here, guys, for each shape that we talk about, have a perimeter formula and an area formula, okay? So the area is base times height. And again, we talked about what the base and height were. Perimeter is pretty straightforward, guys. It's just adding up all 4 sides. Remember in a parallelogram from a few chapters back that the opposite sides are congruent, so they don't have to give you all of the sides because you should know the opposite ones are already congruent. Okay, so find the perimeter and the area of this parallelogram. So if this is 20, then this side needs to be 20. Okay, if this is 32, then this is 32. We know that for a fact. So the perimeter, 32 plus 20 plus 32 plus 20, whatever that is. Okay, what is that, 104. Okay, and then the area, well, you know what, guys, I don't have the height right now. But I do have a right triangle over in this corner, and I can use the Pythagorean theorem to find the height. We're going to see that on the next slide. 12 squared plus the height squared should equal 20 squared. That's going to help me then determine what the height is, and then I can go base of 32 times the height to determine the area, okay? So I've got a little bit of work to do first. Perimeter is easy. We said we would just add up the 4 sides. Area, I first need to find that height, okay? So I'm going to use the Pythagorean theorem. The hypotenuse was 20, and one of the legs was 12, okay? Subtract, take the square root, and you get 16 then for that other side, which is the height in this case, okay? So then when I go half, or when I go base times height, the base was 32, the height was 16, 512. And you'll notice we have square inches. When you're talking about area, it's going to be square units. Perimeter is just units, okay? So perimeter, we added up the sides. Area, we took base times height, but we needed the Pythagorean theorem to help me find that height, okay? All right, so give this a shot on your own and see what you come up with. All right, see how we did. So if this side's 17, this side's 17, and I'm going to grab my calculator. So for the perimeter, I'm going 27 plus 17 plus 27 plus 17, you guys, okay? I get 88. Not too bad. All right, now, to find the area, I need the base times the height, but I don't know the height yet. Okay, so I'm going to use this right triangle over here, and I'm going to say 8 squared plus the height squared equals 17 squared. And I'm going to try to find the height. Okay, so I'm going to go ahead and square everything. So square the 17, square the 8. Subtract the 64. 289 minus 64 is 225. So the square root of that is 15. So now I know my height is 15. Okay? So area is base, which is 27, times height, which we just determined to be 15. 27 times 15, 405. Okay? And so which one has a perimeter of 88 and an area of 405? Looks like B. Again, meters for perimeter, square meters for area. Okay? All right. Ooh, back to our 45, 45, 90, our special right triangles. So finding the area of this, I know the base is 12, that's easy enough. But the height isn't 9, you guys. I know this side is 9. So I've got this 45, 45, 90 right triangle. How do I go from the hypotenuse back to a leg? Well, if you remember, they were x, and x times the square root of 2. So if I've got the hypotenuse and I want to go back to a leg, I divide by the square root of 2 to find the height. You're going to see that on the next slide here. Okay? So they're saying that the height times the square root of 2 is supposed to be 9. So if I divide by the square root of 2, I get a height of about 6.36. Well, now I've got the height. I already have the base. If I multiply them together, I've got the area. Okay? So 76.3 roughly if we round it to one decimal place. Okay? Why don't you give one like this a shot? Okay, let's see what we get. So the hypotenuse of that right triangle on the left side is 12. We said on the previous slide, if I wanted to find the leg of a 45, 45, 90 triangle where I'm given the hypotenuse, I'm going to take the hypotenuse and divide it by the square root of 2. So if I do that, 12 divided by the square root of 2 is about 8.49. Okay, well now I know the height, and I know that area is base times the height. So I'm going to take that number that I got times 16, and I get like 135.8 to one decimal place. Okay? Now they get one, they put it out to 2 decimal places, but the same result. Okay? The key to that one is working this out. Now, what if you forget the 45, 45, 90 information? Because it's an isosceles triangle, I could call this side h as well, and I could go h squared plus h squared equals 12 squared. I'd get the same thing, you guys. So if you remember the Pythagorean theorem, you could work your way through that as well. All right. Area congruence postulate. If two figures are congruent, then they have to have the same area. That makes sense because all of their bases and heights and corresponding parts would be the same. Okay? In a triangle, the area is half the base times the height. And the reason for that, you guys, is pretty straightforward. If I take a parallelogram and I draw a diagonal in, I create 2 congruent triangles. So really the area of a triangle is half the area of a parallelogram. And the area of a parallelogram was base times height. So there we go, half base times height. So you need to buy enough boards to make the frame of a triangular sandbox and enough sand to fill it. If one board is 3 feet long and one bag of sand fills 9 square feet of the sandbox, how many boards and bags do you need? Well, when I talk about boards, I'm talking about perimeter. Okay, so the perimeter, I'm just going to add up the sides. 28, 35.5 is the entire perimeter, but one board is 3 feet long, so I got to take that number, divide it by 3, and see what I get. And I'll do that in the next slide for you. The area, half of 12 times 9. Remember that height is that perpendicular distance. Once I find the area, then I can divide it by 9 to figure out how many sand bags I'll actually need. So perimeter, we're adding up the 3 sides. We said we got 35.5. And the area, half of base times height. Okay? Those are pretty straightforward. I didn't have anything, Pythagorean theorem or any other trig to use to try to figure out missing sides. Okay? And then I need to divide them by the appropriate numbers to find out how many boards and sand bags I need. Okay? So if I take that number of boards and divide it by 3, 11.83 boards, well, you're not going to go to Home Depot or Menards or the hardware store and ask for 11.83 boards. You're going to get 12 boards. Okay? So keep that in mind. Bags of sand, you divide that out, that's exactly 6. So then you can actually get the 6 bags of sand that you need. If it's a fraction, you need to round up in this case. Okay? And that's what they're saying there, 12 boards and 6 bags of sand. So give this one a shot. All right, let's work on boards first, okay? So that's going to be perimeter. So I need perimeter, that's going to be 16 plus 9 plus 20. Okay, so 25 plus 20, that's 45 feet. Okay, each board is 4 feet long. So if I take 45 divided by 4, I get 11.25. So I'm going to need, round up, I'm going to need 12 boards. Okay? The area, 1/2 times the base, which is 16, times the height, which is 12. Okay? Half of 16 is 8 times 12 is 96. Okay? So you got 96 square feet. One bag of mulch covers 7 square feet. So if I take 96 and I divide it by 7, I get 13.7. So I got to round up. I'm going to need 14 bags of mulch. Okay, so just applying what we've learned here, not too bad. So 12 boards, 14 bags of mulch, looks like A is our solution to this one. Okay, the height of a triangle is 7 inches more than its base. So this involves some algebra. So if I let the base be x, then the height's going to be x plus 7. Okay, we're going to see that here in a little bit. And I know that the area is 60, so I can replace the A with the 60. The base is going to be x, and the height is going to be x plus 7. Okay, or b and b plus 7, whatever variable you want to use. Multiply both sides by 2. Distribute here, I get b squared plus 7b. Because it's a quadratic, I need to get 0 on one side. So now I need numbers that multiply to 120 and subtract to 7, if I'm going to factor this, okay? So 8 and 15. If you can't think of the numbers that'll work, use the quadratic formula, you guys. There's lots of methods we have. So b could be 8 or negative 15, but think about it, guys. Does it make any sense for it to be negative 15? Not when it's measuring a distance. So I think the base could be 8, in which case the height is 7 more than that, or 15. Okay? All right. You guys give one a shot. Okay, so it says that the height is 12 inches more than the base. So let's apply our formula. Area is 1/2 base times height. They tell me the area is 560. We're going to let the base just be x, or b, however you want to look at that. And then the height is 12 more than that. So that's where I'm going to start, very similar to the previous slide. Multiply both sides by 2 to get rid of that 1/2. Distribute the x. I have a quadratic, so I'm going to get 0 on one side. And now I got to find numbers that multiply to 120, or 1120, sorry. Where did I? Yeah, 1120 here, sorry. Multiply to 1120 and subtract to 12. Again, you could be playing with that for a little while if you're going to try to factor it. Quadratic formula is just fine, okay? I'm going to factor it because I worked it out beforehand. Okay, so our numbers that multiply to 1120 and subtract to 12 are 40 and 28. Okay, I need a positive 12, so positive 40, negative 28, which means that x could be negative 40, which in context doesn't make a lot of sense, or 28. So I'm going to leave the 28. X was our base, so I think our base is 28 inches, and adding 12 to that, I get 40. I think 40 is our height. So 28 inches for the base and 40 inches for the height. And there's the algebra that goes with it. Okay? There's your assignment, guys. Page 783, 11 through 31, the odd. Please ask for help if you get stuck. And we'll talk to you again tomorrow.